Welcome to Week 10 of Algebra 1 with Mrs. Whybark. This week we will be continuing our discussion of the systems of linear equations, and we will be specifically looking at the substitution method as a means for solving systems. We will once again be using video from the Algebra School program, and you will be using page 195 of their guided notes to follow along. This handout is available on Moodle and will also be distributed in class. You will need a second piece of paper in order to have enough room to show your work when solving these problems.
She came up to me and she had this worried look on her face. Fliegel. Yeah, that's it. Her name was Ms. Fliegel. She said she had a problem that she needed help with. Something big, I assumed. Actually, she had two problems, two linear equations, and she wanted to solve them both. So I says to her, "Have you tried anything, sister?" She just looked at me with all those puppy dog eyes. So I took the job. Right off, I noticed something that only a trained eye could spot. Both equations had something in common. Yeah, they were both equal to y. It took a great detective like me to figure that out. So if they both equal the same thing, then that means that they are equal to each other. Go ahead. Check your rules if you don't believe me. Now the pieces were falling together. Now I had one problem with one variable. I've seen this before. I did it. Made something out of nothing. It's all about finding the common thread. Not bad for a gumshoe who's logged a lot of miles on the mean streets of algebra.
Teachers are so strange.
Well, class, so far we have seen two methods for solving a system of linear equations.
In the first method, we graphed each line and determined the points of intersection.
We have not yet learned the elimination method, but that's the method that we will be learning next week.
In the second method, we combined equations to eliminate one of the variables. We solved for the remaining variable, and then we substituted that value into either of the original equations and solved for the other variable.
Now we're going to learn one more method for solving systems of linear equations. It's called the method of substitution.
Remember that when we are solving a system of two linear equations, our goal is to find all ordered pairs x, y that are solutions to both equations. Each system will have either 0, 1, or an infinite number of solutions.
That's because two lines can have either 0, 1, or an infinite number of points in common.
Here's a system of linear equations for you.
The next two examples are not included on your guided notes. However, I would like you to watch them and follow along, as it does an excellent job of explaining how substitution works.
2x plus 3y is equal to 7. X is equal to 2. We're going to solve this system of equations using the method of substitution.
I thought you were going to show us something new. Isn't this just like the elimination method? We have no y terms in the second equation, and we substitute the value of x into the first equation.
It turns out that we do indeed use substitution in the elimination method. Just remember an important idea. If two expressions are equal, one can be substituted for the other in any equation.
I substituted 2 for x in the first equation. I subtracted 4 from both sides of the equation. Then I divided both sides of the equation by 3 and got y is equal to 1. The solution is the ordered pair 2, 1.
Yes, it is. Let's check the solution just to be sure.
You can check the solution by substituting 2 for x and 1 for y in the first equation. 2 times 2 is 4, and 3 times 1 is 3. 4 plus 3 is 7. It checks in the first equation. 2, 1 is a solution to the first equation.
Any point with an x-coordinate of 2 would be a solution to the second equation.
That confirms it then. The solution to this system of linear equations is 2, 1. Let's try another one. 2x plus 3y is equal to 9. Y is equal to x minus 2.
So, how do we substitute?
Remember, if two expressions are equal, one can be substituted for the other in any equation. What is y equal to in the second equation?
Y is equal to x minus 2. So we can replace any y we see with the expression x minus 2 and not really change anything, right?
You can do that? You can substitute expressions?
That's right. We don't have to be given a numerical value to substitute. In this case, we're going to substitute an expression for a variable. We're going to replace y in the first equation with the expression x minus 2. To solve this system by substitution, replace the y in the first equation with the expression x minus 2.
Okay, that makes the first equation 2x plus 3 times the quantity x minus 2 is equal to 9.
Good use of parentheses, Lizzie. They're really necessary here.
Cool! Now we've got an equation in one variable. If we solve this equation, we'll know the value of x.
And that's what substitution is all about.
Rewrite the equation as 2x plus 3x minus 6 equals 9. Or 5x minus 6 equals 9. Add 6 to both sides. Then divide both sides by 5. You get x equals 3.
The x value of the solution is 3. Now, on to the y value.
You can use the x value to find the y value. Look at the second equation. If y is equal to x minus 2 and x is 3, then y is equal to 1. The solution is the ordered pair 3, 1.
Always check your solutions to make sure they're correct. Now I think it's time to practice some more problems on your own.
Notice that in this example, once they solved to find x equals 3, they plugged 3 into the second equation to find y, but actually you can use either of the original equations. So they could have just as easily plugged in 3 into the first equation and solved for y. Either method is okay.
In question 1 of your guided notes, solve by substitution. Y is equal to 3. 3x minus 2y is equal to 6.
For each of the 5 examples in your guided notes, you need to show all the steps in order to receive credit for your notes. For the first couple problems, you may be able to fit it on the front side of your notes, but for the others, you may want to use a second page.
Since y equals 3, substitute 3 for y in the second equation. To solve, simplify 2 times 3. Then add 6 to both sides. Finally, divide both sides by 3 to get x equals 4.
The solution is the ordered pair 4, 3.
In question 2 of your guided notes, solve by substitution. Y is equal to x minus 3. X plus y is equal to 5.
Replace y in the second equation with the expression x minus 3.
Combine like terms to get 2x minus 3 is equal to 5. Add 3 to each side. And divide both sides by 2. The x value of the solution is 4. Now go back to either one of the equations in the system and substitute 4 for x. Since y equals x minus 3, we get y equals 1. The solution to this system is the ordered pair 4, 1.
In question 3 of your guided notes, solve by substitution the system of linear equations 3x plus 4y is equal to 18. 2x minus y is equal to 1.
Begin by solving the second equation for y. Then, you can substitute the expression 2x minus 1 for y in the first equation.
Now simplify and solve. 3x plus 8x minus 4 equals 18. 11x equals 22. So x equals 2.
Take the value for x and substitute back into one of the original equations. I chose the first equation. 3 times 2 plus 4y equals 18. 4y equals 12. So y equals 3.
The solution to this system of linear equations is the ordered pair 2, 3.
In question 4 of your guided notes, solve by substitution the system of linear equations 3x plus y is equal to 2. 6x plus 2y is equal to 7.
Solve the first equation for y. That gives you y equals negative 3x plus 2.
Notice that in this step, what they wanted to do was solve one of the equations to have a variable by itself. Since the first equation has just one y, they subtracted 3x from both sides so that they ended up with y equals negative 3x plus 2. Now that they solved for y, they're going to take this expression, negative 3x plus 2, and substitute it into the second equation for y.
Now substitute the expression negative 3x plus 2 into the second equation.
Use the distributive property to simplify the left side to 6x minus 6x plus 4.
Since the equation becomes 4 equals 7, which is false, the system of linear equations has no solution.
In this example, they tried to solve for the first variable, but once they came up with the equation 4 equals 7, which is clearly false, they were able to determine that these two lines formed by these equations will not have any points in common. Therefore, they can stop at this point and conclude that there will be no solution.
In question 5 of your guided notes, solve by substitution the system of linear equations x is equal to 3y plus 7. X is equal to 2y minus 1.
Since both equations are solved for x, the expressions 3y plus 7 and 2y minus 1 are equal.
Set the expressions equal to each other and solve. Subtract 2y and 7 from both sides to get y equals negative 8.
Substitute negative 8 into one of the original equations to find the value of x. In the first equation, x equals 3 times negative 8 plus 7. X equals negative 17.
The solution to the system of linear equations is the ordered pair negative 17, negative 8.
Take a moment to think about what a solution really means. This means that I have the point -17, -8. I could plug this point into either of these equations and it would be true. That means if I graph the lines formed by these two equations, these lines will intersect exactly once, and they will intersect at the point -17, -8.
So, there you have it. When you see a system of linear equations, the clues are all there. Just find that common thread, x or y, and use it to your advantage. Make something out of nothing. Turn two equations in two variables into one equation in one variable. That's your ticket. Listen, guys, it's time for me to scoot. I've got to meet with Ms. Fleigel and tell her I've cracked the case. Gumshoe Frogan has rescued another damsel in algebraic distress.
When completed, your first page of notes should look like this. Notice that for examples 3, 4, and 5, I only have the solution written. However, you do need to show all of your work. Therefore, I have a second page of notes that shows each detailed step in solving those systems. You can use any piece of paper for your second page. I recommend that you do not use the back of your first page because these notes will be added to your interactive math notebook. Thank you for watching this Whybark production.